This video is sponsored by PCBWay. More about them later. This is Mark, a multi-directional articulated rolling cube. The inspiration for developing this robot came from trying to add steering to Fred, my hexagonal folding robot. There have been many suggestions for ways of incorporating directional control in this design, some of which I've explored in previous videos and others that I plan to showcase in the future. One suggested solution was to add the ability to roll from left to right rather than adding steering. This could be done by essentially creating a second hexagon perpendicular to the first to roll from side to side. But because of the complexity involved in doing this with a full hexagon, I decided to instead take this approach with a simple square, and thus Mark was born. For my past robots, I've made a lot of custom control boards on Protoboard to connect different components together. This works great for one-off designs, but when you start making as many robots as I do, it can start to get pretty tedious and time-consuming. So for Mark's control board, I'm going to be using a custom PCB, courtesy of PCBWay. PCBWay is a one-stop shop manufacturing service that can make custom printed circuit boards, 3D prints, and machine parts based on your designs. They make it easy to customize board parameters to fit your project's needs. Personally, I'm a big fan of their matte black solder mask with a white silk screen for a nice clean look. For my control board, I wanted to design something universal that could be used for a wide variety of robotics projects. I designed it around the Seed Child microcontroller boards because of their small size and wide variety of offerings, all using the same footprint. I also incorporated an NRF24L01 transceiver to communicate with my remote control and other robots. The rest of the pins are wired to some standard servo headers for hooking up servo motors, sensors, and other peripherals, and an I2C header for communicating with future expansion boards. The design also has optional components like a motor driver chip capable of driving two brushed motors and a 5-volt regulator. The design files for this circuit board are available at my GitHub, linked in the description. If you're interested in ordering these boards or any other circuit boards, check out PCBWay for an affordable and streamlined ordering process. Thank you PCBWay for providing me these boards and sponsoring this video. For Mark's code, I tried to keep things pretty simple. The main logic of the loop waits for a directional command from the controller, and then changes the robot's shape twice to roll in the desired direction. Since Mark can only roll in all four directions when it's sitting on either its top or bottom face, I included a routine to check which face it's sitting on when it's stationary using the microcontroller's built-in IMU. If it isn't on the top or bottom, it automatically transitions to them so that it's ready to roll in any direction. For the physical design, I used 4 servo motors spread around the robot and placed them so that they wouldn't collide when the robot changed shapes. Technically, this design only needs 2 motors to fully constrain its motion, but I decided to use 4 so I could drive the opposite faces in parallel to increase strength and reduce slop. I rounded all of the rolling surfaces so it could more easily transition from one face to the next, and I added these TPU bumpers to better grip the ground. Since this design uses a square linkage instead of a hexagon, its rolling is pretty limited. While Fred can statically shift its mass past its current footprint to tip to the next side, Mark has to rely on the momentum it generates while moving to dynamically roll to the next face. This makes rolling more timing dependent and less consistent, especially when going over bumps or uneven terrain. With that being said, I'm pretty happy with how Mark turned out. Here you can see its automatic self-righting in action, which works pretty well. Let me know in the comments which new robot variations and types you'd like to see in future videos.